Hello, 6th grade. How is everyone today? I hope we've all had a good day. So today's lesson is going to be about kinetic energy, mass, and speed. Now we've already learned about kinetic energy and the other types of energies in physics and science, but we're going to focus on kinetic energy today. So today's standard is to analyze and interpret data to show the relationship between kinetic energy and the mass of an object in motion and its speed. So the outline of today's lesson is we're going to overview what kinetic energy is, what mass is, and what an object's speed is. And then we're going to learn what is the relationship between kinetic energy and the mass of an object and its speed. And what is our goal for today? Be able to take data and find the kinetic energy based on the mass and speed given to us. So kinetic energy of an object is the energy that it possesses due to its motion. So we all have kinetic energy. And that is given to us by this equation. So kinetic energy equals 1/2 mv squared. But what does m and v stand for? We've already discussed mass and velocity. So in this equation, m stands for mass and v does stand for velocity, but today we're just going to think of it as the speed of the object. Motion is the change in the position of an object over time, and the mass of a body is its inertia or resistance to change of motion. Speed is the distance traveled per unit of time. Pretty simple definitions. We kind of all really understand it, but it's good to just see it written out and be reminded. So the relationship. So mass, the kinetic energy of an object is directly proportional to its mass. So if the mass has units of kilograms, then the kinetic energy will also have a unit of kilograms. And also with the joules, which is the kinetic energy unit. For speed, it is also directly proportional to the square of its speed. So what does that mean? For a 2-fold increase in speed, the kinetic energy will increase by a factor of 4. For a 3-fold increase in speed, the kinetic energy will increase by a factor of 9. And then for a 4-fold increase in speed, the kinetic energy will increase by a factor of 16. So let's look at an example. So I'm going to show you how I would do it, or we're all going to do it. So just watch me first. So we're going to find the kinetic energy of a 71 kilogram man walking at 1 meter per second. So we're going to use the equation that we were given earlier. So 1/2 mv squared. So we're going to type it into our calculator. 1/2 times the mass, which is 71, times the speed or velocity, which is 1, squared. So you get 35.5 joules. So this is another one. So find the kinetic energy of a 71 kilogram man running at 5 meters per second. So it's going to be really similar. So you plug it into the formula. 1/2 times 71 times 5 squared. So this guy sped up a little bit while he was running, or he started running instead of walking. So you just plug it into the formula, just like that. You can type it exactly like that in a calculator. Don't forget to use your parentheses to make sure you get the 1/2 correct, because sometimes it messes up. You get 887.5 joules. So together we're going to try this one out. So this is a table that has a object speed, mass and speed. So there's 4 objects, and we're going to find out which of the objects have the same kinetic energy. So we're going to use our formula, 1/2 mv squared. We're going to plug it in one at a time. So for object A, 1/2 times 1 times 4 squared. I think that's what I have up here. Yep. And I get 8. So for B, we're going to do the same thing. 1/2 times 2 times 2 squared. Should be 4. Yep. The next one, 1/2 times 0.5 times 4 squared. Don't forget that squared. Another 4. And then for the last one, it's 1/2 times 4 times 1 squared. Will give us 2. So looking at the answers of the kinetic energies, 2 of them do have the same kinetic energy. And it looks like it's B and C, which looks like that's the 4th answer on this little chart. That's right, B and C. So we're going to have a handout from today's lesson to put in our notes. It's always good to have our notes here in science. And this is a really good little handout. It kind of helps you figure out stuff and remember what we learned today. So basically we just have our formula, Ke, which is kinetic energy, 1/2 mv squared. Helps you remember what each thing stands for. And it helps you remember that kinetic energy is the energy that objects possess due to their motion. So we're going to put this in our notebook. It's going to be helpful for you to remember the equation because we have a lot of equations in this chapter and section. So it's kind of gets difficult when you have so many of them. And we're going to have an exit ticket so I can see if you guys learned and remember everything. So what's the equation for kinetic energy? You can find that directly on your handout. And what is the kinetic energy of the following? So I made up some numbers and we're going to just do the same thing that we were doing in the lesson. I just want to see if you guys understand. And if you don't, I'm going to go back over it tomorrow. And I want this done, completed, and turned in before class is over so I can look at it tonight. And I can talk about it tomorrow and see if we have any problems. And then after that, tomorrow, we're going to experiment. So be prepared to go outside and have your lab materials ready because we're going to find our own kinetic energies. We're going to do a lot of different motions, a lot of speeds, and we're going to figure out what our kinetic energies are based on our mass. So yeah, hope you guys have a good rest of your day and see you tomorrow.